let's get started. We are going to go over the final exam today. That's why everybody's here, I think. I posted this lecture that I'm going to go over in a few minutes. I posted it out here. It's called Summer 2012 Final Exam Review. If you click on the link, you'll get that file, and the file is a 964-final that I'm going to go over. And the final exam, if you're not aware yet, is next Monday, a week from today, on July 2nd. And all of your assignments for the Java course are also due on July 2nd. So hopefully you're finishing that stuff up. For this particular class, we've gone over all of the assignments already. And you've got some really good tutorials, and you've got some good videos and stuff that practically show you all of them. So you don't really have to worry about the assignments. And the assignments are only worth 25% of the grade anyway, so it's not that big of a deal. Another 25% of the grade is on the final exam, which is a bigger deal. It will be in class, closed book, closed notes, closed internet, closed neighbor, closed everything. And you'll have to bring a photo ID with you. The TAs are going to be checking IDs. I don't know, maybe it'll be someone from the Learning Resource Department. I'm not quite sure how this is going to work really. And the same thing with your attendance today. It's going to be run a bit differently than it has been in the past. But make sure to bring a photo ID with you. If you don't have a student ID, don't worry about it. If you have a student ID, that's the perfect ID to bring. But if you don't have one of those, don't worry about it. You can just bring any ID. It is worth 25% of your grade, 25% of your final course grade, that is. So what I want to do is spend a few minutes going over this and letting you know what is on the final exam. And I brought a copy of the final with me, actually. So I'm going to pull the final exam out here. And I can tell you it's 4 pages long. And it is 25 questions. Make sure, actually. Hold on a second. Yes, 25 questions, 4 pages, so they're evenly spread out. And they're all multiple choice, so it's all multiple choice. And it's covering the following subject matter. And what I'll do is I'll kind of cross-check as I go through the points to see what's on the exam, so I can kind of make sure we've got everything. I've covered everything, that is. So the basic concept of object-oriented design techniques and the concepts, aka a PI. And there are at least 7 questions on this particular topic. As I went through and I counted them. And these are broad questions, such as what's a class or what's an object. And if you haven't figured it out already, the acronym of PI stands for abstraction, polymorphism, inheritance, and encapsulation. So the 7 questions are on those 1, 2, 3, 4 topics. So in terms of the object, that's an abstract. That would fall in the abstraction category, and the implementation of the class that is, becomes an object when the object is created. That concept, the concept of polymorphism, what it is, how it's used in the language. Be familiar with some examples of polymorphism. Also, the concept of inheritance, how do we extend one class from another class, and the concept of interfaces as well, which is going to be covered further down in another bullet point. And then encapsulation, there really isn't anything in terms of programming that we covered specifically for encapsulation. It's more of a concept, sort of like abstraction. And encapsulation, if you remember, is taking the entire concept of, let's say, a car engine and calling it an engine. So we're hiding all of the details of all of the implementation of that. We don't know that it has different parts. Hold on one second, let me pause this here. We're going to do our attendance. Hold on. Let's try and pick up where we left off. Sorry about that interruption. Hello, we're back. Hello. Okay, so we only stopped on item number 1 if you came in late. Oh, we have another thing? Oh, pen. Okay, good. Oh, perfect. No problem. All right, so we want to know about these 7 different questions that are going to be on this particular topic. What we're looking at is a PI, just to pick up where I left off, and the PI is a abstraction, polymorphism, inheritance, and encapsulation. So there's 7 questions on those particular topics. And I was going through, I think before I got interrupted this, I didn't get too far into this. I was going through like examples of each one of them, and I think I covered that part. And I believe I stopped at saying that encapsulation is more of a concept, not really a programming thing. Inheritance is, however, so the questions regarding inheritance, you won't have any programming questions where you actually have to write source code, but you'll have to know about the programming aspect. knowing that extends, the keyword extends is used for inheritance, and implements is for an interface, you know, that kind of stuff. The keyword class used to define a class, you know, the syntax for it. But you don't have to write any code. So there's some questions where you'll have to look at code samples, and you'll have to tell me, you know, is this right or wrong, kind of thing, and what's happening in this particular example, kind of thing. Which is the nature of the assignments, nature of the questions. There's about 4 of them. Quickly looking through, I see about 4 that actually have like pieces of source code in it. Okay, so none of it's a whole program, it's just snippets. So item number 2, knowing, unless we have questions, because this is also your opportunity to ask questions, like, is there going to be a question on such and such? And then I can say no, or I can say yes, there is a question on such and such. But if there's anything just comes to mind as I go through this, just let me know. Knowing the concept of the method or the function and how the parameters are passed with a method call. Also be familiar with method overloading and overriding functionality. At a bare minimum, you want to know the differences between overloading and overriding a method. So overriding complements it. And what I'm giving you is a brief definition. It's not all the information from the entire course. I'm just in case you're not familiar with the concept, this is what I'm talking about. So overriding replaces it. It actually kind of hides it, so you can't use it, the original. In fact, instead you're just reinventing it. And overloading makes it so that the old one is still there, but the new method is also now accessible as well. So you have twice as many, essentially, when you overload versus overriding. Why do you want to overload? In the concept of constructors and overloading constructors. You overload a constructor when you want to create a constructor to take on 3 parameters instead of 2, because you want to pass the information back to the previous constructors in the use of inheritance. As an example, we have a base class called person. It might have a person's name and an age, perhaps. And then we can create an extended class on person and call it employee. And then employee might have name, age, and employee ID. In that case, you're overloading that method, the constructor method. Or I shouldn't say method. I shouldn't call the constructor a method because it really isn't. It's a special method. It's a constructor. But the concept of it being is that you're overloading it when you create a new constructor that takes on 3 instead of 2 parameters and sends those 2 supers then back to the previous object's constructor and reuses it. So everything's available to you. That's not overwriting, because if you overwrote it, you wouldn't be able to use it. It'd be hidden. As an example, if I had one that said set age, and I repeated set age with the same signature, which means it's the same name of the method and the same number of parameters and the same parameter types, etc. and so forth, created a new method that matched identically to the old method, and I put it up into an inherited class, I'm overwriting the existing method that existed that was going to set age in this particular example. Because when I say my object.setAge, it's going to pick the last one I created, and it's going to overwrite, and I can't really get back to the previous versions unless I upcast that object back to something in another form when they wasn't aware of that other method that I wrote in order to run that other method. In this particular case, I'd have to cast an employee back to a person to run the method that was actually implemented in the person object if it's overwritten. So if you overwrite it, you're basically removing it from the scope in terms of the object space. So those concepts like that are on the exam. So be familiar with the keyword static and why and how it is used with variables and methods. Know the difference between class and instance level variables and methods. Also, probably goes without saying that you want to know the differences between data members, member functions, what they're used for, in terms of data being stored about the object, and then behaviors. Functions are the behaviors on the messages that are being sent back and forth between the objects. And the differences between the static and the instance. So we know instance variables exist, and we can create referenced instances of objects, and we call it, person space person1 is equal to new person. We've created an instance of the object person1, and it's being referenced by instance of the object person that's being referenced by the person1 reference object, which is an instance because we've created a new person, created an instance of it, versus the class level where we talk about person dot something to run a method on the class, and that when we run a method on a class, it affects all instances that are out there. And when we run a method on an instance, it just affects that one instance. So we can have 5 instances of the object. They can each have their own name, their own age. But we could carry, in fact, this is from one of the homework assignments that you had, we could have a static method that updates or a static data member that updates or keeps track of a student ID or a person ID, as an example, a social security number or something like that. The concepts that were in the assignments are the ones that are being tested on the exam. So if you've done all of the assignments, you will ace the exam because you already know all these concepts, so, in theory. So if it was covered in an assignment, most likely it's going to be covered in the exam. So let's see, being familiar with keyword static. Also knowing the concept of garbage collection and how memory is managed, how it's managed and used with the JVM. There's no pointers in Java. And the fact that, well, this is probably an easy one to know about because we don't actually have, in fact, I gave you the garbage collection lecture on last class meeting. We talked about garbage collection, and there really isn't that much really that you have to know about it, actually. There's only 1 or 2 questions, perhaps, on the entire concept. But the idea is that we don't have pointers, we have automatic memory management. We can create and use objects, and then they're automatically, when they're no longer being referenced or used, they're automatically collected, and the space is recaptured for use with other programs or other objects and stuff. So it's all done automatically for you. But knowing the concepts, essentially, which is core to the Java programming language, which is kind of the core concept of Java. The concept of abstraction, how to create abstract classes. Different terminology than I used originally when I came up with item number 1, where I talked about abstraction, polymorphism, inheritance. But it's still the same concept. Abstraction is abstraction. So knowing what an abstract class is, how to create one, how to use one, why you want to use one, and knowing what an interface is, and it's probably further down the list here, but the interface as well. So in terms of the abstract class, you missed attendance, by the way. If you want to get on it, I'd run upstairs and see if you can catch Joel. If you want to get on it. Otherwise, it's not going to be taken anymore. Okay. So the concept of the abstract class, which is essentially the class that doesn't have any implementation. It's declared as being abstract. It's used in inheritance just like any other ordinary class, except for nothing's being implemented inside of it. Instead, it's empty. It's sort of like a template in some cases, which is providing a foundation that's going to be built on, hopefully, in the classes that are inherited from it. Versus the interface, a class can be inherited, and we know that Java is a single line inheritance, I hope, at this point, where we can inherit one class from another class. So class A extends class B. It doesn't extend class B, comma C, comma D, comma E, like it does in other languages. Instead, we can implement interface 1, interface 2, interface 3, interface 4. So we split it out, essentially. So we've created multiple line inheritance by splitting it out. And in terms of the concept of their abstract class versus the interface. The interface is not a class. It's an interface. And it's declared as an interface. Abstract classes are classes. They're just declared as being abstract. So how and why would you want to declare a class as being abstract? Well, any class that has any abstract method must be declared as abstract. So you have partial or you have full implementation going on in terms of the methods inside. In fact, you can have a completely created class with a ton of functionality and with one abstract method in it, so you've made the entire class abstract. You have to if you're going to use it that way. And then you can inherit from it. And what does that mean? Well, you have to implement that unimplemented method. If you don't implement the abstract method, you get a message that comes back and says, excuse me, if it's an interface and you don't implement the unimplemented method, your compiler will come back and say, hey, you have an unimplemented method. And if you're in Eclipse, it'll say automatically for you, would you like to include these unimplemented methods? And you say, okay, and it creates basically the unimplemented methods. With abstraction, you can delay, in fact, you can also delay interface implementation as well, just by declaring it but not implementing it. You can delay the implementation of the abstract method until it's actually going to be used. So you can keep it abstract through inheritance line until you actually use it. That's when you're going to implement it. And so why would you want to do that? Well, if you have functionality that's going to change with inherited classes. As an example, going back to the shape concept, which I gave you during the lecture that was on this particular area, we have the base shape. And the shape might have a diameter, might have some dimensions, and it's going to be different if the shape is a triangle versus a rectangle versus a cylinder, solenoid, or something. It's going to be different. So if we say that we want the area and we declare it as an abstract method in the beginning, then we don't have to come up with a fake area that's not going to work correctly. So because the area of a circle has a shape and the area of a square as a shape is going to be totally different. So if we implement it in the beginning, we end up with a problem of that area being used inappropriately or having a wrong value associated with it. Plus, also, we have to go through the labor of actually implementing the method as well. So what we can do is just create that method as an abstract method and say, hey, we want an area, and we're going to use this area further down in our inheritance, but we're going to let the inherited classes define what they mean by an area, in terms of the implementation. So we can set different formulas for each one of the calculations. When we use an interface is an abstract class, but nothing is implemented inside of it. Instead, what it is sort of a template. It says we're going to have shape. Let's say shape is an interface as an example, maybe. Then we would use that, and we would have to implement certain things. And in fact, what we're doing with an interface is we're saying this interface, if it's a person interface, it's going to have legs and arms and all these body features, and we have to specify characteristics about it. And so when we create a person who's an employee or a person who's a staff or something, we want to require the programmer to implement that functionality. So we create an interface, we make that interface part of the implementation, which kind of guides the programmer through the implementation of that particular object. So it's used for guiding. It's also used for setting standard behavior for that object. It also can be used for tagging. Remember the tagging concept? So if a object is a relationship with another object, which we have in all of the inherited classes, we can interface to tag to say that this particular student is an ITU student because it's implementing the ITU interface, student interface. The ITU student interface has a student card or something, or has all this information that's associated with these particular sets of students. And so we can check the student and say, well, is Bob, is he an ITU student? And if he has an interface included in his implementation that tags him as a student, ITU student, then obviously it's also an instance of that object as well. So it would come back and say, yeah, true. But maybe Larry or Curly or Mo out there who are students at other universities who have different interfaces associated with their implementation are going to tag differently because they have different implementations of the different interfaces. So interfacing can be used for tagging. It can be used for setting a model, a standard. For example, if we have cars and in our development environment, each one of these cars, in fact, let's talk about stock actually. You don't have to do this for the stock program, for the stack and the queue. But if you had a stock, in each stock you created an interface for it. You don't have to do this, by the way, but if you did, the stock would have a price, a symbol, buy date, a sell date, I don't know, and these would be requirements for each one of the stocks. So that if you created a Google stock or Yahoo stock or something, and these are different inherited types of stocks as an example that came from the stock that implemented the stock interface, we would expect them to all have symbols, all have prices, all have information. Because what we can do is create a bunch of different types of stock, and we want to be able to run consistent methods on them, like get price, set price, get symbol. And if the method's not there, our program's going to fail. So, and pick kind of another example of formality, or conformity, excuse me, trying to think of that word, where all objects are going to have certain methods that are all the same methods, like toPrint or something, toString or something like that, that's associated with the object. Actually, if you haven't figured it out already, every object has a toString method, and I mean, we saw that in one of the examples actually I gave you, because every object inherits from object, and object has a toString. So we can run toString on everything, essentially, and it works, which is kind of an example as well of the interface. And you can actually change, you can change that toString and can overload it, and you can overwrite it as well. So, all right, so there's a concept of abstraction, how to create abstract classes, interfaces, how to create and how to use them, how to create a class that uses an interface or is derived from the base abstract class. There's at least 4 questions on that particular topic, actually. And the questions that are on the topic are theory-based. Let's see if I can find any of them. They are... one's about an abstract method. One's about an interface, using an interface, class implementation. There's an inheritance question actually about single, double, multiple, kind of different types of inheritance. So abstract classes, abstract inheritance. Yeah, there's about four questions on there on that concept itself. But what I gave you was kind of a summary of the information I'm talking about that falls into that category. And so feel free to stop me as I go through this if you have questions. So how to derive a class that uses both an abstract and an interface. Actually, kind of just said that a few minutes ago. Class A extends class B, implements C. We know the C is the interface in that particular case. All right, have a syntax for the class declaration itself. You know, class person number 1, person number 2, whatever class you're creating. Not written in here, but I did see it a few minutes ago when I was thumbing through it, was the public and the private concept as well. Kind of basic. I saw a couple of questions. In fact, here it is right down here, access modifiers. Knowing the differences between when you want to use public and private, etc. We know that the data members are always private and the methods are always public. We know the concept of the driver program, I hope by now, the classes. So we create class objects, and those objects get instantiated in a driver program, and driver has main in it. And not all of our other classes have main in it. They only have the class implementation. And when we make instances of objects in main, we can create many different mains that all use the same objects, which gives us reuse in the language as an example of another kind of object-oriented characteristic. So let's see, being familiar with the basic concept of building a hierarchy of classes that includes abstract and interface classes. Another thing to mention on this particular concept, and just another point to reiterate, is the concept of how and why we're doing this. Okay, so I've already mentioned that we're inheriting classes from other classes. I would hope to, reinforce the reusability concept. Why reinvent the wheel when you already have a concept of a shape, you already have a concept of a person, and you're building, but the hierarchy itself should be structured in sort of a descending or ascending order depending upon how you're looking at the hierarchy. As a particular example, we always start at the top, which is the super level, which is upside down for me, because I always would start at the bottom and work up. Hierarchy actually starts at the top and works down in terms of the concept, because super is above sub, and super has less functionality in it. So the super object of all is the object, right? So as soon as we create any object, we're already subclassing from object. And in Objective-C, we say NS object. In Java, we don't say anything. We just create class person. So class person is already at level 2 because object's above it. And then when we create class employee that extends class person, we're moving down and we're actually creating more functionality. So now we have employee that has person that has object. So not only are we building the hierarchy in terms of what's being part of the particular object, at the same time we're getting more specific. So we're being now more, instead of just an object, everything could be an object, a shape, a person, a house, everything's an object. So that's not as very specific, that's very broad. as soon as we create a person, all of a sudden we've specified now, getting rid of all the other object concepts. And we're saying, well, okay, this is a person. And then when we say employee, now we've narrowed it even more. So the concept of narrowing and widening, the higher we go up the hierarchy, the wider we get. Because now we have objects, in fact, at the top, highest level of the object, we're as wide as possible. But when you start looking at employees who are students, or no, employees who are people who are objects, we've narrowed it down. So that concept of upcasting, as I mentioned before, goes up the hierarchy to cast. But we get wider in terms of the concept of what the object encompasses. And we get more specific or narrow the further down in the hierarchy we go. There's a couple of questions that get into that concept. So it's not, it's not data conversion. It's not casting, like type casting. But it's similar, that it's working, casting up and casting down the hierarchy is working with traversing the different levels of the hierarchy of what might be enclosed inside of the object. So that's why we use the is-a relationship, if you remember that. So we can see what it is, so we know we can upcast it. Because if this object is a BMW, we can't cast it to a person, because it's not going to work correctly. And we can't take an employee and cast them to a car class. Not going to work. So we use the is-a relationship to see what the person is. And in the last programming assignment, you have to use the is-a relationship to actually figure out that array of objects. What are those things? Are they teachers? Are they students? Who are they? So that you can figure out, and if you watch the video on that, it actually will make a lot more sense to you probably. Who are these different objects, so we can test who they are. So we can run a class method to give the teachers, make them know about their students, and vice versa, if I wanted to. Alright, so knowing the fundamentals of creating Java programs, from classes to main methods to driver programs. I call them driver programs. They're really just main methods. Be familiar with where to place main and why. And when it goes in one, there's only one main in the entire set. If you put main, and this is the reason why you're not supposed to put everything all in one class, the whole program in one class. Because when you reuse the class, you're going to get a compilation error because you're going to have multiple mains. If you have a main in every one of your classes, you can't reuse anything. You have to automatically, at one point you got to pull it out of there. So why put it in there at all? But a simple example for a homework assignment or something. I get lazy. I put it all in one file. But in theory, if you want to promote reuse, you break it out. So main only goes in one, and it's the driver program, and you're not identifying in assignment number 3 that has 5 objects inside of it. You're not declaring all these different objects because eventually, are you going to make new instances of assignment number 5 every time you want to use something that's enclosed inside of it? Because every time you do that, you're going to have all those 5 objects when you're really only using one of them or something. So, and the other point also to make with that is that another reason why we have reuse and we separate everything out is going back to the concept of memory. Do we want to really load in 5 objects of miscellaneous type and have them loaded in memory every time we make a new instance of the assignment number 5 object? So if we make it all separate, if we want to make a person object, we're just making a person object and just allocating memory for person. And we're allocating memory for employee. We're allocating memory for whoever we're happening to create. So we're not loading anything that's not necessary for what it is that we're trying to do. So let's see how to create classes. For example, using the class name as the file name with case sensitivity. We also hopefully know at this point we can't call it something else outside of what the class is labeled. So if it's called student, it's been going to be in a file called student.java, and it turns into a file called student.class. And if the S is lowercase in the file, it's lowercase in the implementation of that class. And hopefully we know right now the best practice is actually to make all classes uppercase. The first character is always uppercase, because then that's the way we can tell the differences between a class object and a non-class object in the language. In fact, if you haven't noticed it, all the class objects like string is all uppercase. The first character will always be capitalized because that's the concept essentially. Okay, and we all know that we all need all the files together, either in the same package or in the same directory in order to run the program. So let's see, I talked about this one already, but the differences between a public to private use of classes and data members, at least 2 questions on that particular topic. It's kind of a core concept, actually. So, let's see. The knowing how to create instances of objects and invoke methods on those instances. So creating a method inside of a class, making an instance of that object, and then running the myPersonNumber1.getName, myPersonNumber1.setName, and knowing that those are accessors and modifiers. And actually, if you know the terminology, it'll help you if you're taking the Objective-C class, because these are actually created automatically for you in Objective-C, which is you'll love if you're taking the Objective-C class actually next year. You'll love it because it's C++ and Java, but more automated. So you create an instance of an object, you already get the setters and the getters for you automatically, which is kind of like why I'm kind of well, actually every Java course will reinforce this concept, because this is core to object orientation, is the set and get, which is equivalent to the accessors and the modifiers. So a modifier sets, changes the behavior, and is usually associated with each one of the data members. So in Objective-C, when you create a class and you have 3 data members, you're coming out with 6 automatically created functions for you, if you're having it do it automatically for you, which you can do on the iPhone platform actually. So you have a set name, a get name, a set age, a set get name, a get age, blah 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 blah. 2 sets of methods for each one of those data members, give them to you automatically. In Java, you create them automatically, and they're called setters and getters sometimes, or accessors and modifiers, depending upon which words you like better. So the concept is the same. So set and get methods, being familiar with that concept is important, because those are public methods that are used to basically modify private data. So, knowing the constructor concept and how to create one. Also the concept of multiple constructors. Knowing the concept of how the constructor is executed, what is the order from base to derived, etc. And also be familiar with the concept of the method signatures. So we know what a method signature is, hopefully. It's the core concept of how we overload and override, and that's the way we create constructors. So we know that the constructor doesn't have a return type, and that the constructor is the same name as the name of the class, and that the constructor signature is its parameter list. So if we have a constructor with no signature, no parameters, it's the default constructor. And then we have as many constructors as we want that we can create. We can have one that takes on, if we have a class that has 3 data members, we could essentially have 4 constructors out of that in different combinations, because we could have, well, actually I can come up with more than that, but you can just multiply it out actually, because you can have, for example, you can have one constructor that doesn't do anything, that would be the default constructor. You can have one constructor that takes on parameter number 1, one that just does number 2, one that just does number 3. You can have one that does 1 and 2. You can have one that does 2 and 1. You can have one that does 1, 2, and 3, or 3, 2, and 1, or 2, 1, and 3. Basically multiply it out and you have that many number of combinations. Imagine just the number of combinations that you can get out of 3 parameters. You can create a lot of constructors if you'd like. Why do you want to create a lot of constructors? That gives you polymorphic behavior in terms of the concept of polymorphism. Same concept is true for methods. A method with a name that has a different signature. For example, method print. It's just a generic method called print. And print takes on a parameter that's an integer. And then we have another method. In one particular object, we have print that takes on an integer. We have print that takes on a float. We have print that takes on a double. Print that takes on a string. And so we say object dot, or whatever we call that instance of the object dot print. And we pass it an integer, we pass it a float, we pass it a double. That's polymorphic behavior, because we've created an object that has the ability to respond to different method calls with different number of parameters automatically, depending upon what you gave it. So it morphs per se. We also have polymorphism when we have an object of one type that turns into another, but it's also another. So we can take an object that's an employee, turn it into a student. Actually, we can take well, probably not an employee to a student, unless it was a student to begin with, but let's say an employee and a student, we can turn them into people. That's polymorphism, when we take one object and we turn it into another object by upcasting it to another object form. And it makes it compatible. So all these objects that we have out there, actually every single object out there is compatible because they're all objects. So we can morph, using polymorphism, any object into an object and store them all together. So we can get around arrays of multiple different data types, actually. Put all these objects in there. We can use object as a data type, actually. Say object something, obj or something. Use that as a parameter type. So any object can be sent to a method as an example in that particular case. For example, if you had an object that was doing copying, you could essentially create an old-fashioned C++ copy constructor by creating an object with a method called copyMe. And copyMe took on an object, and what ended up happening was you called that method of that object. You copied me, and I was a person, and it would make another copy of a person by taking all of the data members and getting the information from the object and making a copy of it, creating a new object, and essentially creating instance of that object and setting all the data members to exactly the same thing that the first one was. And then maybe you sent copy method an instance of BMW, which was inherited from car, which came from somewhere else. It can also do the same thing. So, because it's basically going through the generic type object as a parameter. Slight tangent, but not a bad concept to be familiar with, only because it gives you more capabilities in terms of solving problems with compatibility in terms of types, object types. You have the same thing that you have with types, built-in data types. But you have the capability of making more generic data types when you introduce the object concept, because you can take everything and make it into an object. We saw that with the data structures lecture, where we had built-in linked lists and arrays that were just storing objects. And the type was not typed, so I could put numbers, floats, integers, and everything in there. Only problem is when you go to use it, you have to actually, look at this. What is this item? And run an is a relationship on it or something. Hey, are you a float? Are you a double? Are you an object of a person? What are you? In order to actually manipulate the data. So, all right. So know the constructor concept. We all know a signature. Those are the footprint. I'm not going to give you an entire list of, like some teachers. Actually, it's more of an undergraduate thing when they give you, a whole printout, and you're just like, what? Or they ask you, here's a bunch of constructors. Tell me what's being printed out on the screen, and you have to traverse through each one of the different objects that get created out of this 10-story high inheritance of all these. No, it's not going to be like that. But do know that when you create an object, the first constructor that runs is running from the base. The base is object. So you're running from the top of the hierarchy down to the bottom. When the object gets destroyed, it actually goes in reverse order, which is the same way as it works in C++ actually. But we don't see it because we don't have destructors. We don't have copy constructors either, because we have built-in destructors and built-in copy constructors. If you don't know what that means, don't worry about it. You have nothing to get confused with because you don't know, but that's how C++ implements it, however. So. But what you're looking at in terms of the concept is knowing the order, so we can, which is alluding to the concept of this and super. So we run super, and I call it super back, to come from a higher level object down to a lower level object, because what we're doing is eventually we're going to have a complete object, but we build the object from the base up. So from a constructor that resides in a derived class, we can super back to the base classes, because those are always going to be created first. So we pass information back through the base by using super. When we want to get to this object, we use the word this, because we want to know this person's name. And we can do that because some information might be hidden between the layers. We can cast and go, this person. Then we know that this person is going to be whatever object this person thinks it is. Whatever hat it happens to be wearing at that moment in time when you asked it, it's going to pull back that piece of information that you're looking for. If that makes any sense. So, that concept's in there. The this and the super. Here it is down here on the bottom. I remembered it, but I skipped it to item number 13. So let me I'll go back to 12 in a second, but knowing how and why to use the keyword super in this and what the concept is doing as relates to constructors and other parts of the class. So we know that when we set from this current class, for example, we have object and we created person that automatically got inherited from object, and then we created employee. As an example, that was a type person, extended from person. In the employee class, we have certain information. We can go this dot first name, or actually employee is not going to have first name and last name. Person's going to have first name and last name. Employee might have employee ID. So we can specifically say, if we have an ID as an example, this dot ID, or this dot something, to know that it's coming from an employee level object. And we can super back to person, the first name and the last name and stuff like that. Normally the convention in some languages require the this dot, name, or this dot age or whatever. In Java you can leave it out. So you can just say, name is equal to whatever name you picked up from the command line when the constructor ran, or whatever piece of information the method took in as a parameter list or something like that. So you're constantly assigning parameter values to data member values. Not constantly, but to initialize the object essentially. And we know that default constructors can initialize things that are consistent among all objects that are created. So we stick initializations in the default constructor. We don't put them up with the data declaration. So if we say, let's say we're going to have a Fahrenheit, we're going to have a temperature. We want to set the Fahrenheit to 0 and the Celsius to 0, or excuse me, the temperature value to 0. Because maybe we're going to have the ability to create a temperature without actually creating a value for the temperature. We just want to create a temperature object. And if we ask the temperature object what value it is, we want to have it to come back and say 0. Or maybe there's a string value that says not set or something. So we don't go at the top of the code in the data section. We don't go, private integer value is equal to 0. Instead we go private value, or integer value, I should say. We declare it, and then we initialize. If you're familiar with the concept of variable declaration plus variable initialization, the initialization always goes in the constructors, which is why we have constructors. So getting back to the concept, I'm not going to review the entire course, getting back to the concept of those constructors, they're there to initialize the data. That's the only reason why they're there. And they're invoked automatically. You can't call a constructor. You can explicitly, let me rephrase that. You can explicitly invoke a constructor. You're not really calling it, but you're invoking it by creating new instances of objects and sending it different parameters. Depending upon the parameters that you send it, it's going to come back and pick the constructor that matches it. If no constructor matches it, it's going to come back and say, hey, sorry, error message. There's an error message in your code essentially at compile time that's going to say, hey, problem. But you can't say my object dot run constructor number 1, run constructor number 2. It doesn't work that way. So you don't run, which is why they're not methods. Because by definition, a method is a behavior that you're asking. It's a message that you're telling the object to do. Like, get me the name or set the name. You're explicitly invoking that instead of implicitly invoking it when you when you create a new instance of a new object. So let's see, let me go back to number 12 here. Know the concept of the subclasses and the superclasses. Inheritance, yes. Also be familiar with it is a member. I already talked about that. Yes. This is an object. Student, teacher is also an object, a person. The second programming assignment. I believe that's now the 5th programming assignment, so that's wrong actually. And the concept of the object identity upcasting, I already covered that as well. So that's pretty much what's on the exam. What's not on the exam? You don't have to worry about. No questions on collections, packages, swing, or AWT. No questions on exception handling, language syntax, source code writing. We haven't seen it yet, but no questions on nested classes and interfaces or network programming. I'm going to talk about nested classes and interfaces today a little bit. That's the last part of the last lecture, but I'll probably finish it on Wednesday actually. Who knows? I did give myself till 6:45, which is good. But it's because the problem with this is that depending upon your implementation that you're working with, you could be working with AWT or you could be working with Swing for that notepad assignment. And everyone's going to be actually focusing on different areas of it. It's going to be really hard to test you on the entire package. And it's not really a course in which we're trying to learn different packages. So that's why there's no questions on collections. And there's no questions on, let's say, thread programming, because those are all packages. So you're importing a package and you're running methods and you're creating instances of objects from, you know how many packages there are out there? And there's tons of different I'd have to test you on every single one of them. But that's not really, you know, that's not really testing you on anything. So the majority and the entire exam is focused on object orientation. So it's all about object-oriented concepts and how they apply to Java and the object-oriented features of Java. So don't worry about not knowing the Swing or the AWT, or I'm not going to ask you what's in Java util. I'm not going to ask you anything associated with packages. And not even the package concept, but you probably know that by now. So that would be almost too easy to ask you a question on packages. So let me go through and see if there's anything in particular that I missed. As I go through here, some questions on classes and objects, references to objects. Questions related to the components of an object. I didn't mention this, but what are the 3 components of an object? Identity, state, and behaviors. Every object has an identity associated with it. It's a person. It's an employee. Its states are the data members. And this was actually covered like in the first object-oriented lecture I gave you, if you can remember. It was 8 weeks ago. The states are the values that are set for data members. As an example, if it were a temperature object, we would have a value that's associated with the temperature, whether we're in Fahrenheit or Celsius, you know, that kind of stuff. If we were a stopwatch, our states would be: is it running? Is it stopped? Starting? You know, elevators would be: what floor are we on? Behaviors would be switching between different floors of an elevator, turning a stopwatch on, turning it off, which is the setting and the getting. So the methods, the sets and the gets on the methods, are the behaviors. We turn on, we give a value to a temperature, we set value, get value, kind of stuff. And then the states are essentially the values associated with those data members. And then, of course, the identity. So one of the biggest problems in object orientation, and then not really on the exam, but just on the side comment, is the lack of identity in the object. When we create an object called assignment number 5, what does that really tell us about that particular object? Nothing. Well, it's an assignment you did for a course. That's probably much all you can remember about that. So I always try to think, well, the identity is sort of like when you name a Word file. If I call it my file number 1, file number 2, file number 3, file number 4, about a year from now I'm going to go back into my documents directory or wherever I have my files. I'm going to go, where's that spreadsheet I did on object orientation and the final exam review? Oh, wow. Is it in object number 1, object number 2, object number 3? So the identity is really the name of the object, if you think about it. And then in object orientation, the identity is important because if we have a car, it should act like a car, unless it's a hybrid and it's a boat and a car, which we do. Do we have boat cars? No, we have boats, planes, seaplanes. Perhaps we have boats and cars that are together. Who knows? That's a bad example then, I guess. But okay, chair versus car. 2 completely different objects. I wouldn't want to label that chair a car because I'd probably get sued because it won't go fast enough on the road. And then we don't want to bring our cars into the classroom and sit down on them either. So, because I'd probably get sued if I sat on somebody's car because they'd say, "Hey, you're scratching my car." So, hopefully you get the comment. So, let's see. There is one question that's not on the review here about passing data. We do hopefully we would remember, in the beginning of the course. In fact, one good way to review, if you're like, oh my god, that's a lot of concepts, and it is a lot of concepts, just go back through the lectures. Go back through the PowerPoints from the beginning. That's really, if I covered it in class, it's on the exam. One of the things I covered in the beginning, way beginning part of the class, was the differences between pass by reference and pass by value. And we know that in Java, everything is something. It's one or the other, right? It's always reference. Everything's reference. But it's always treated like a value. So because we don't have references, we don't have pointers. But when we pass the object as a parameter, it looks like it's by value because we say, you know, take on object obj. And we send it a car, we send it a boat, it looks like it's a value, but it's really a reference because it takes the object and puts it in there, and it can change the object because it's actually working with the object. So the concept of the value is sort of missing, but everything looks like it's a value, if that makes any sense, because we don't actually have to say that we're not referencing it. It's automatically referenced. But yeah, there's no way of sending anything explicitly by value. It's already by value. Excuse me, by reference. So, although it looks like by value, we could make it by using the keyword constant, actually, but we're not going to worry about that. That's not on the exam, actually. So, overloading, overriding is on there. I covered that already. Abstract methods. Can we have abstract data? No, why would we have abstract data? How can data be abstract? Data can't be abstract. We can have abstract methods, though, right? We can have abstract classes, but data is data, isn't it? Yeah, if it was abstract, if it didn't exist, perhaps, but yeah. We can set default values in a constructor. That's a good question, theoretical question. Why is main special? What's so special about main? Yeah. It's Java's only way of knowing that this is the starting point of the execution of the program. If you have a bunch of classes and you don't put a main in anything, you get, the first exception you get is, can't find main, main's missing. But main can go anywhere you want. And if you have multiple mains, it goes, oh, which one of these mains do you want me to start in first? So main, even though it's a method, it's like kind of the starting point. I mean, it signifies the placeholder for the starting point of execution. Everything starts with main and it goes, if it's not in main, it doesn't get executed, essentially. So that's why they call it the driver program. Let's see. How many references can you have for a single object? Multiple, yeah, as many as you want. Thousands of references to a single object. Okay. The difference between the object and the reference, if we say new person, we've created an object. Can we create an object without a reference? Yeah, anytime we say new anything. We don't actually have to have a reference. So the reference is the pointer from a C++ perspective, but you guys don't use pointers, so it's a person, my person is equal to new person. And so when I want to look at this new person that I created, I'm referencing them through this labeled description that I have called my person, which makes that a reference to the object. So we can create references to objects, and then we can create the objects, and then we can assign the references to the objects. We can create references, or we can just create the objects. New person, new car, new boat, new train. That's legal syntax. But how are you going to reference? How are you going to use this new thing? How are you going to give it a name? That's the reference to the variable. And you can have multiple references to the same object. You can have multiple instances of the same object. So you can have car number 1, car number 2,500. And you can take the references, and you can assign them to any one of them that you want. But it's usually one reference is at one moment in time assigned to one instance of one object normally. However, you can change the reference. So it's sort of like that linked list concept. You can follow references from object to object. You can take a reference that's pointing to one object and have it assigned to another object. References are very flexible that way. Sort of like variable names, if anything. So, you know. So let's see. What else? Oh, I was going through here. Let's see what else I forgot. Let's see. Can an object be a subclass of another object? Yeah. So everyone can be a super, everyone can be a sub. Except for object. Object can't really be a subclass. It's always super. The super object. How can you subclass object from anything? It's the main superclass. But that's not that would be a trick question. It's not on the exam. But the concept is that it's the highest level object. It's the superest object of all object. So you can't put anything above it. You can always just put stuff below it. You can subclass from it. But it's never going to be a subclass to another object. So it's kind of like, if you believe in God, it's like saying, well, is there a God above the God? No, it's the highest level. So same thing in object orientation. It's very religious, this object orientation. The super object. Actually, there was a sitcom, and I can't remember what it was. And then there was on like Channel 9, like the PBS Public. Couple of students put together programming. It wasn't Java, it was a different language, but it was like a real life program where you had objects in it was object-oriented concepts, but you had real life characters that were playing objects. And there was a super object, and it was actually kind of entertaining. Only problem is you'd have to actually be kind of a strange, weird nerd in order to actually appreciate it. It wasn't very mainstream. But, actually it was kind of interesting. It was very relevant towards, but very abstract at the same time. So, let's see. Interface questions, abstract questions. Something about polymorphism, signatures. I think I covered it all, actually. I'm looking to a brief look through it. Looks like I covered everything. Questions about the final exam? Okay. It's not Wednesday. It's Monday. Okay, I'm going to end this one and start a new one.